And if everybody can remember to mute themselves, that would be helpful.
All right, I'll open the gates.
Yeah.
Okay, Chiara, should I begin or should I wait another few minutes?
Just maybe another minute. Let's have a look.
Okay, let's get going. So good afternoon, everybody. My name is Gerard McCarthy. I'm from Maynooth University and I'm here representing the Blue Action Project. And I'd like to welcome you on behalf of the 4 projects here who have co-organized this event: Mission Atlantic, Triatlas, Blue Action, and So Chic. I'm going to start off just with a bit of the housekeeping for these events while people are still filtering in. This is a Zoom meeting. It is being recorded as we speak, so please be aware that it is recorded. When not speaking, please keep your microphones muted and your cameras off. When you want to ask questions, there will be a Q&A box for the panel discussion. So please type your questions into the Q&A box and please indicate which of the speakers or panelists the question is for. We'd also like to know who's asking the question, so please do identify yourself when you ask a question to the panel. As an outcome to this event, we will publish a short report summarizing the outcomes of the discussion. So welcome here today. As I was saying, this is an event co-organized between our 4 projects. We are all research and innovation projects. We are all funded by Horizon 2020, and we all have a very Atlantic focus. We're contributing to the Galway Declaration and the Belém Statement, and contributing to understanding science and implementing science diplomacy throughout the Atlantic. All of our projects are joined as we work on topics related to climate change, to the Atlantic Ocean, to the environment, and to biodiversity. We are all contributing to the All-Atlantic Ocean research community. In this event today, we have a number of exciting speakers lined up. So we're going to start off with, in a few moments' time, with Mission Atlantic, with Mary Weiss, is going to speak first. And then we have the science evidence of the challenges, scientific challenges ahead. This is going through the 3 projects, including myself representing Blue Action, Jean-Baptiste Salé representing SOCHIC, Southern Ocean Focus Project, Elaine McDonough from Norse representing the Triatlas project, looking at Atlantic and climate-based ecosystem prediction. To wrap up, we've got John Bell representing the European Commission, who will present a vision for the future for these for European science. I'm very happy that we have Sheila Heymans, the Executive Director of the European Marine Board, here today. Sheila is going to act as our Master of Ceremonies and will chair the panel discussion. So we're here ahead of the start of a very exciting 2-day All-Atlantic event. But not only that, it is also the start of the ocean decade, and we are facing into an exciting summer with the IPCC AR6 report being published a little bit later on. So this is an exciting and important time in ocean science, in Atlantic science, and in science diplomacy. So I look forward to these talks and panel discussions as they unfold over the next hour and a half. So without further ado, I will pass over to Sheila, who will chair this discussion.
Thank you very much, Gerard. Everything is moved around now. Very good. So welcome everybody. It's wonderful to have so many of you here. As Gerard said, I'm going to chair moderate the session, and I am going to start off by introducing the first presenter, who will be talking about the Atlantic Ocean challenges and integrated ecosystem assessment. The work will be presented by Mary Wise. She is from the World Maritime University, but it also encompasses work from my good friend Andrei Polyak, who's one of her students and who I know for a while already. So I will let you take it away, Mary, if you want to share your screen. And yeah, you've got your 10 minutes. 7 minutes.
Okay. So good afternoon, everyone. You see my screen? So
we do, thank you.
Thank you. Okay. So in this presentation, which sets the scene for this session, we're going to discuss ocean science diplomacy, which is the intersection of ocean science and international affairs. We will show you how ocean science diplomacy can be a powerful tool that can make the world a safer and more peaceful place. But first, I should point out that to help ocean science diplomacy achieve its potential, we must be open-minded to looking at the world in more inclusive ways. And this is why in the map behind me, we're showing the Atlantic from a south to a south on top perspective. So, but what is ocean science diplomacy? Ocean science diplomacy can be any of a few things. It can be science in diplomacy, and this is where scientific evidence informs negotiations and decision-making. So examples of this could be the science to support the IPCC, the Convention on Biological Diversity, the Convention for Migratory Species, UN Fish Stocks Agreement, hazards forecasting and prediction, and maritime zoning, things like this. It can also be diplomacy for science. Nature knows no administrative boundaries, and ocean science is cooperative, transboundary, and requires vast amounts of resources. No single nation can do it alone. Diplomacy fosters joint global ocean research projects, monitoring, information sharing, and capacity building. Examples of diplomacy for science are initiatives such as harmful algal bloom monitoring and forecasting, the Seabed 2030, our very own All-Atlantic Ocean Research Alliance, the Global Ocean Observing Systems, the OBIS Ocean Biodiversity and Information System, and the UN Decade of Ocean Science. So those are examples. Ocean science diplomacy can also be science for diplomacy. Shared challenges and threats encourage coordinated and problem-driven scientific cooperation and also dialogue between countries to inform better decisions. Examples of science for diplomacy are the governance and management of fish stocks that are driven to move away with climate change. Could be the governance and management of sargassum blooms in the Caribbean, and also marine research projects between conflicting nations. The All-Atlantic Ocean Research Alliance is an example of ocean science diplomacy. It's based on 3 international agreements and bilaterals between the EU, Argentina, Cape Verde, and Morocco. The agreements are the Galway Statement, the South-to-South Framework, and the Belém Statement. Together, they span the whole Atlantic. The All-Atlantic Ocean Research Alliance supports cooperative research for societal benefit. It bridges communities beyond research, and it's also open to other countries, and it can serve as a model for other basins. Cross-boundary, societally relevant scientific efforts, such as we face in the Atlantic, require ocean science diplomacy, and diplomacy benefits from such large collaborative research projects. Integrated ecosystem assessment is the focus of the Mission Atlantic project. It relies heavily on ocean science diplomacy and also advances it. Integrated ecosystem assessment, or IEA, is the comprehensive integrated management of human activities based on the best available scientific knowledge about the ecosystem and its dynamics in order to identify and take action on influences which are critical to the health of ecosystems, thereby achieving sustainable use of ecosystem goods and services and the maintenance of ecosystem integrity. Mission Atlantic will use the integrated ecosystem assessment approach and its research to analyze different approaches for science diplomacy to inform ocean governance on a basin scale for the Atlantic. It collaborates with stakeholders to identify and address societally relevant research questions, and it also evaluates options for the co-creation of IEA decision-making tools and indicators. Through the work of the All-Atlantic Ocean Alliance, we are learning to become better ocean science diplomats together. This event will present and discuss how ocean science diplomacy can help make society safer and more peaceful through the Alliance and through its work by bridging communities informed by research. Today, with this session, we are going to discuss pole-to-pole connections through research projects that are beyond the capacity of the scope of the Alliance. We are going to discuss the power of ocean science diplomacy in building stronger ocean and polar communities and fostering knowledge for policy and society. We will discuss the role of ocean science diplomacy in the UN Decade of Ocean Science for Sustainable Development. We'll discuss opportunities to bring balance to scientific capacities in the Atlantic. And we will also discuss how we can integrate research projects going forward. Thank you. Enjoy the presentations and the discussion.
Thank you very much. Thank you very much, Mary. So that was a very good overview to start off with. Now we are going to go to the sort of the science session that kind of gives you the science evidence of what Mary has proposed and what Gerard has talked about. And we will start first of all with Gerard, who you've met before. So Gerard McCarthy, he's from Maynooth University, and he is going to be presenting the Atlantic Arctic Ocean Circulation and Impacts. So off you go. Just a reminder for those of you who came in late, if you have any questions for the speakers, please put them in the question and answer at the bottom of your screen. And please put who the question is for, and we will take these questions after the presentations when we're in the panel discussion. So Gerard, the floor is yours.
Thank you very much, Sheila. So thank you everybody for attending today. It's my pleasure to present some of the results that we've had from the Blue Action project. Blue Action is a project that is focused on Atlantic and Arctic ocean circulation and impacts, and thanks to my fellow project members for many of the slides here today. Now we're here teeing up the All-Atlantic event over the next 2 days, and I'm going to start off by talking about the tropical Pacific. So in this slide here, what you can see is a model of the ENSO effect, so of the ENSO processes. At the top, you can see flashes of red to blue, the red being El Nino events and the blue being La Nina. So this is a coupled ocean-atmosphere process, and it has very many important climate and weather impacts around the whole of the globe. The reason I'm starting with El Nino is because it is quite a developed example of how coupled ocean-atmosphere dynamics and their understanding can lead to real societal impacts and societal benefits. El Nino, one of the impacts of El Nino is that it causes severe flooding in Peru. So this severe flooding can really impact the farmers that live there. It's no good to these farmers to have an insurance policy that plays out after their crops are ruined. The hardship is already in there. But by understanding the coupled ocean-atmosphere dynamics of ENSO, it has led to the development of an index-linked insurance policy. And this insurance policy pays out when a physical indicator, sea surface temperatures in the Pacific, hit a certain threshold. We're going to go back to the Atlantic now because this really kind of encapsulates the building blocks of what Blue Action is all about. So we have two core building blocks of observations and computer models. The observations and computer models are really what we build our understanding of the physical processes around. Observations in situ and remotely sensed tell us about what is happening in the ocean and in the atmosphere. And then computer models take those on, integrate those observations in certain instances and deliver, and I'm particularly going to highlight delivering decadal climate predictions, which are essentially weather and climate forecasts that are delivered out to timescales of maybe 2 to 5 years. When you understand the physical processes, when you can see what is happening, when you can model what is happening, you can start to develop climate services and deliver societally relevant and tailored forecast products. I started off talking about El Nino in the Pacific Ocean. What would an equivalent process be in the Atlantic? So I'm going to take you up to Mullaghmore in northwest Ireland. So this is Sligo, and this is maybe not a particularly balmy picture of Sligo, but it is palm trees growing. And this is palm trees growing at a latitude of 54 degrees north. Now that's a good bit north. If we were to flip the globe over and look at what in the way that Mary likes to do and Mission Atlantic does to fit our view of the Atlantic and look at the southern hemisphere, we'll be down in South Georgia. So South Georgia is a sub-Antarctic island at pretty much the same latitude south as Sligo is to the north, but the climate is very, very different. In Grytviken, you have glaciers surrounding it and have a snow-filled landscape for much of the year. So what's the difference between the North Atlantic here and the South Atlantic? Well, there are many, many differences, truth be told, but I would like to draw your attention to one process in particular, and that's the process of the Gulf Stream system. I guess we would talk about it popularly, and scientifically we would refer to it as the Amoc, the Atlantic Meridional Overturning Circulation, which is a system of ocean currents that carries warm, shallow water northwards and brings cold, deeper water back southwards again. This transfer of warm and cold water leads to a very large heat transport, the largest ocean heat transport of any basin in the North Atlantic. And it brings heat up past Ireland, up past Scandinavia, and really kind of impacts the climate of these regions. Within Blue Action, we have supported the sustainable observation of the Amoc. So the Amoc observing system is illustrated in this slide here, where we have the green dashed lines illustrating the systems that are in place for observing the Amoc. These include some of the longest supported by the European Commission projects, including the measurements across the Greenland-Scotland Ridge, GSR. Between Greenland and Scotland, there's been a system of measurements going on since the mid-1990s. More recently, the OSNAP system has been deployed between Scotland and Canada via Greenland. But throughout the Atlantic, we are in actually a very rich phase of Amoc observing. We have arrays stretching from the Samba array in the south, which is a multinational, multi-continental observing array that measures the South Atlantic Amoc, all the way up to the Greenland-Scotland Ridge and beyond. So we are in a situation where we have comprehensive observations of the Amoc. Now, whether we have sustainable observations of the Amoc is a very different question, actually. These projects are in place and typically are supported by short-term funding. So Blue Action has been working to support, optimize, and assess the best way that sustainable observations of the Amoc can be continued into the future. So why would we want sustainable observations of the Amoc? So I showed you this figure already and talked about how the Amoc consists of currents, including the Gulf Stream and the North Atlantic current, and how that links to the milder climate of the Northwestern Europe. Now, the slow propagation of these warm anomalies actually has a very important benefit, and the very important benefit is that it leads to predictability. So the numbers on this diagram illustrate the propagation of these warm anomalies as they cross the Atlantic. And this is work that was developed by colleagues in Bergen throughout Blue Action. So we have an observed process that is important for climate. And not only that, it's predictable. And this is a very good situation to be in because it allows us to take on and develop the climate services that we really need to do to take this information to society. Blue Action has worked on a number of topics on this throughout the project. We have looked at risk assessment of extreme events, polar lows, and the impacts on shipping in the Arctic region. We have looked at heat waves, heat health throughout Europe, and how predictability can impact that. I'm going to focus in particular here on fish forecasts. So a number of the sister projects that are presenting here today are focused on looking at the integrated overall Atlantic process of ecosystem and fisheries management. And in Blue Action, we have done our part too. If I take you back to the start of Blue Action in 2017, there were no forecast products, fish forecast products in Europe. These were the preserve of the North Americans and the Australians. Throughout Blue Action, building on the work particularly of Mark Payne and DTU Aqua, we have developed fish forecasts for blue whiting and for garfish and other fish species. And this really allows us to take the next step on, which is integrating these fish forecasts into management. We are interested in the Amoc as well because we think we are confident that it is going to change in the future. Successive IPCC reports have reported that the Amoc is very likely to weaken, and in fact that an abrupt Amoc collapse is a possibility. Now, that's not considered to be a likely possibility, but it's probably a probability a little bit higher than your house burning down, and you probably have insurance for that. The recent changes that have been going on in the Atlantic are quite shocking, really. In 2015, there was a record cold anomaly just south of Iceland. In 2016, there was the freshest anomalies that was ever observed in the Atlantic. So record cold anomalies are a very unusual thing these days. It's usually the other way around, and we usually get record warm anomalies. We usually get warming effects. So we do suspect that the Amoc is weakened, but there are a lot of questions that we don't understand. One in particular is how far away we might be from a tipping point of the Amoc. So we have done a lot. There's a lot more to do. The building blocks of Blue Action have been working on long-term sustained observations that are critical for monitoring and understanding the ocean. Building climate predictions on the basis of understanding these physical processes, and finally transmitting this physical process knowledge into climate services that are valuable and actionable and of real societal benefit. So thank you very much. I will leave it there, and I look forward to the panel discussion shortly.
Thank you very much, Gerard. That was great. And I see that we have questions that's come in for both the previous speakers, so that's good to see. So our next presenter is JB Saleh, who is from CNRS in France. And he is going to be talking about the Southern Ocean dynamics and climate. And I will leave you to your 7 minutes now. Take it away.
Thank you, Sheila. So, Gerard told us about the North Atlantic, the northern part of the North Atlantic. I'll switch to the southern part of the Atlantic system. And more generally about, I'm going to speak about the Southern Ocean. And what I'd like to discuss today, or to present today, is the key role of the Southern Ocean for regulating climates. For most of us, the Southern Ocean is a very far and remote place on Earth. And so there's a legitimate question, which is, why should we care at all about the Southern Ocean? There's, of course, the unique and fragile biodiversity. There's the natural beauty of the system that we should probably all care about. But today I'll discuss beyond that and discuss the key role that the Southern Ocean has for our daily life all around the planet in terms of mitigating climate and in terms of climate impacts. So to do that, I'd like to start by showing this figure of atmospheric warming over the past 50 years. When we look at this figure, we see a global warming. This is no surprise, which is amplified in the Arctic. But there's an exception to this warming, which is quite striking on this figure. That's the no warming or the slight cooling around the circular belt of the Southern Ocean. And this is actually a direct fingerprint of the Southern Ocean circulation, which acts as a pump for it to take it from the atmosphere and to export it in the deep seas. So that's in this way that I like to talk about the Southern Ocean as a thermostat for our planet. It's not only doing that for heat, but it's actually doing that for carbon and heat. Those numbers are quite striking. 40% of carbon and 75% of all the heat that are absorbed by the world ocean are actually absorbed in the Southern Ocean. And so if we want to be able to address key policy relevant questions like linking emission to atmospheric warming, for instance, a key question that's in the policy arena is, how much can I still emit to reach 1.5 degree or 2 degrees of warming, Paris agreements? We need to address that question. We need to understand the ocean pump of heat and carbon, and especially what's going on in the Southern Ocean, which is the place where most of the action is happening. So that's what we do as part of the SOCHIC project. We really try to dig into this question, and we do that by looking at fine-scale processes from observation and idealized numerical model, and to look at how those fine-scale processes that make this pump working, how they impact climate by looking at long-term observation system and a system model. But it's actually more than heat and carbon. Southern Ocean controls many irreversible climate change aspects. So if we want to understand this, we need robust information to clarify societal choices on evidence base. So what I have in mind when I talk about these reversible changes, for instance, I've got in mind the melt of the ice sheet, the loss of the Antarctic ice sheet. So we know today that the Antarctic ice sheet has been losing mass over the past few decades. We know that this loss of mass has been accelerating over the past decade. And we also know that this is all due to the Southern Ocean interacting with the ice shelf, which destabilized the Antarctic ice sheet. What we don't know is how those processes are working. And that's because we still have a lack of understanding or poor understanding of Southern Ocean processes and cryosphere ocean interaction. And this places make us face what we call, that's the designated term, deep uncertainty in terms of sea level rise. For instance, here I've got one example showing this deep uncertainty at the end of the century, up to 2 meters of sea level rise. This is a major uncertainty, a major weakness for our adaptation strategy. So we must narrow down those uncertainty by better understanding Southern Ocean and ocean cryosphere, ocean ice sheet processes. When the ice sheet melts, it's actually at the freshwater layer at the top of the ocean. And that's a bit like adding oil on top of water. That changes the structure of the ocean. And we see that very clearly in the Southern Ocean. That's from a paper that we recently published as part of SOCIC, where the red patches, I don't go into the details of this figure, but the red patches in the Southern Ocean indicate this fresh water at the top of the ocean that tends to stabilize the ocean. And this stabilization of the ocean makes it more harder for the circulation to connect the surface to the deep seas. So that will slow down the circulation. And when we change the circulation in the Southern Ocean, we've got a problem, because that's global, there are global ramifications. Here I'm showing the global ocean circulation in a projection that I like to show, which I think places the Southern Ocean where it should be, at the central of the ocean circulation. And so when we start when we start stabilizing the ocean, we slow the circulation, as I mentioned, and that's what the climate model project, a slowdown of the ocean deep circulation, which mirror and which is very similar in terms of processes as the slowdown of the Amoc that Gerard was mentioning. What we don't really know, and we should better understand, is what is the interplay between the Southern Ocean and the North Atlantic circulation in terms of their change, or the slowdown of the Southern Ocean circulation and our interplay between each other. A change of the circulation has regional weather impacts. Gerard told us about the impact of Amoc in terms of regional weather. For the Southern Ocean, a recent paper that we also published as part of SOCIC, this has different regional impacts. Here I'm showing one example for the Equatorial Pacific with strong implication in terms of precipitations. So all this science needs to feed science, society, and science diplomacy. And we do that by contributing to assessment report. For instance, as part of SOCIC, we have many of us, three of us being author for the coming report, including myself. And we also, our output, of course, feed those reports, and also through a science policy briefs like this one, or science dissemination more generally. So I'll leave it here with a few recommendations. We really need long-term sustained observation of the Southern Ocean. This is a remote place, but we need to understand it better than we do now. Results from climate model remain very uncertain for polar region, and in particular, this is due to our lack of understanding of the ocean ice shelf, ice in general interactions, so we need to improve that. We need also to better understand the role, the interplay between Amoc and the Southern Ocean circulation through the Atlantic basin. And finally, I believe we need to make change in the Southern Ocean more tangible and awareness to raised because of its importance for adaptation and mitigation strategy. Thank you. I'll leave it there.
Thank you very much, Debbie. So that was a great presentation. We now have our final science evidence presentation, which will be given by Elaine McDonough. And she is going to talk about the Atlantic climate-based marine ecosystem prediction for sustainable management. As Gerard was saying, she is from Norse, and she is going to be telling us about the Triatlas project. So I think we can see your slides, and I can see you. So take it away.
Great. Thank you very much, Sheila. So thank you for the introduction. My name is Elaine McDonough, as Sheila said, and I'm going to be giving you today a flavour of the work that we're doing in the Triatlas project. So within Triatlas, our ambition is to develop the understanding and capacity required to predict marine ecosystems and their societal impacts. So Triatlas is one of the All-Atlantic Ocean Research Alliance flagship projects. It runs from 2019 to 2023. So right now we're about halfway through the project. The project is made up of 33 partners from 13 countries and 3 continents. And so with partners from Brazil, some coastal states in Africa and across Europe. Our focus in this project is in the subtropical South Atlantic and also in the tropical Atlantic. Okay, so within the project, our aim is to make climate-based predictions of marine ecosystem and consider the impacts. The tools that we use that are observations and models, and we use those of both the environmental, ecosystem and human dimensions. We use the combination of those tools to help our understanding, so to create new knowledge about the ocean. And all of this feeds into our ability to predict. The strategy that we use to improve our knowledge and understanding is to consider those drivers that will change under climate change. And on this slide, I've just included a few of the parameters that we consider. So one of those is ocean warming. So I've just shown here the global temperature record from the 1850s, showing dramatic warming in the last few decades. So this is the climate stripes that many will be familiar with. The ocean takes up 93% of the heat in the climate system. So the ocean is warming, and those warming effects have an impact on ecosystems. We're considering that within Triatlas. Another element that we're considering is variability in the ocean circulation. And I've shown here the prediction of one element of the ocean circulation, the Amoc, which Gerard and JB have both referred to also. So this shows predictions from 16 different of our Earth system models, all of them reducing into the future. So we are anticipating systematic changes in ocean circulation, and what we want to understand in Triatlas is how that interacts with ecosystems. We are also considering extremes within the project, and we have a particular focus on marine heat waves. Over the last few decades, we've seen marine heat waves increase in frequency, duration, intensity, and extent, and we expect that to persist into the future. So we're considering how those marine heat waves interact with ecosystems. And the final example that I've given here is of human indicators. So how climate change impacts communities and changes their motivation to fish and to generally interact with the ocean. So this is one example of the science that we're doing in the subtropical South Atlantic. So this is a large-scale study which has looked at the tuna catch in the ocean. So that's the bottom of the panel shown here. And you can see that in 2012, there were peaks in the tuna catch. That's both for big eye tuna and for albacore. When we look at what was happening in the ocean then, we see that the temperature decreases in accordance with that increase in tuna catch. That's the top panel. And then in the center panels, there are indicators of ocean circulation. So we're beginning to link the changes in ocean circulation with changing water properties and discern their impact on the tuna catches. This picture shows the social indicators of vulnerability in communities around the South African coast. So it shows vulnerability to change of particular indicators, and those indicators are things like poverty or housing stock. The vulnerability to change demonstrates how a community will change its interaction with the ocean based on changing those indicators. So a high vulnerability means it's likely to change, and a low vulnerability means there's more resilience. So this kind of model isn't new, but its implementation at a community level is new. And each of these different sets of bars that you see here represent a different community going around the South African coast. This type of regional community-based approach feeds into the regional consideration of social economic drivers that we're considering within Triatlas. So we take our environmental conditions and understand their variability. We then link those and understand the impact on the lower trophic levels and then on to the higher trophic levels. In addition, we consider how human activities interact with those higher trophic levels. And then we include that in a modelling framework, which combines both Earth system models, which is what we use to predict climate change in the Earth system, and also combine that with marine ecosystem models that include these highest trophic levels. We are focusing on seasonal to decadal timescales, as these are very novel, but also very relevant for managers. So our ambition is to move from a system where ecosystem prediction is done offline and in a non-integrated way with the Earth system models, and include all of the ecosystem models through to all of the highest trophic levels in an integrated climate prediction system for a digital Earth. Okay, I just wanted to say a few things about project implementation and legacy. So we are building this project and working across a new community, which is an exciting advance. We are using, it's very multidisciplinary and is observing and modeling physics, fish and humans. We are implementing multiple new technologies. We have a significant training component, including CARNEMS, which we are contributing to and building on. So that's the Cross-Atlantic Network of Excellence in Marine Science. We have, that includes multinational cruises and summer schools. And while we have hosted or contributed to events to both cruises and summer schools, these have been impacted by COVID more recently. We also have elements of technology development within the project, and I particularly wanted to draw attention to the self-reporting fish catch app that has been produced by our Brazilian collaborators and is used by small-scale fisheries to report fish catch, which both informs the science that we're doing, but also is an important element of citizen science. I'll stop there, thank you.
Thank you very much, Elaine. So that was great. We have now had the 3 science presentations, which is good. So now if I can get John Bell, I'm hoping, I see he's there, but I have not seen him yet. I see he's there twice, which is even more. Ah, John. So I will introduce John now. He is the head of the Healthy Planet Planet section of the he's the director of the, let me try that again. He's the director of the DG on research and innovation for the Healthy Planet. And he has been working on ocean issues since I started at the Marine Board. So it's nice to see you again, John. And I think you have 10 minutes, if I'm not mistaken.
Yeah, it may feel longer than that, Sheila. Thank you very much, and thanks to Andre, and those were absolutely magnificent presentations. So my job in the European Commission is to try and harness the research innovation capability we have to drive this great transition that the European Union is trying to lead to become a climate neutral continent working within its environmental boundaries in a fair and just way. And to do this, we're going to need to have a systemic transition that is driven by systemic science speaking to society. And the title of this piece I was asked to speak on by Andre was, you know, what is our vision for the ocean? I would put it very simply. Here I will stand back as somebody dealing in the interface between science, policy, and citizens. Our vision for the ocean has to be a vision of the ocean. It needs to be a vision of the ocean that is integrated, accurate, predicted, and publicly understood and embedded in our daily lives. And as we will see, the ocean needs to become something which is not remote or pastoral or distant, as some of you said. It has to be seen as second nature, a natural part of our identity, our society, our policy, our economy, our production and prediction, and our ambition as a society. And the current crisis we're living through, which is a turning point in our civilization, where we will have a lot of the readouts this year at the COP, at the IPBES, at the Global Biodiversity Forum later in the year. It shows us that we're living in a society where we have become denatured. Our humanity has become denaturalized, our society decoupled from its home here on planet Earth. And so the oceans, and to see the oceans for what they are, they've become something of a blind spot for policy, for society, for the economy. And to see the oceans for what they are, to build this vision, and to see what they need from us and what we need from them, we have to use science, research, and public engagement to renature our identity, to restore our environment, to regenerate our communities, and to co-create a renewable economy and a sustainable and fair society. I think some of the slides earlier on, you see the very real impacts that are ahead for some of the most vulnerable parts of our world. So to become renaturalized citizens of this future, we have to research the knowledge, the prediction, the ecosystems, the observation, the dynamics, the processes, and we have to set a new ambition for science and research in setting a direction, setting a course for what has to be a transition by design. Science must step up now to speak with society. We know that everything begins in the ocean, and the ocean remains beyond this great community of people who've gathered here in the Azores. It's a blind spot, and it has to be placed in the center of our vision. We do this transition by design by having a great conversation that needs to be based on scientific observation, prediction, and fact. Science needs now to map, to observe, to predict, to sequence, to model, to explore, to adapt, to de-risk, and to demonstrate its situation and our choices. We need to address the great life support system of the Earth in systemic ways. The word systemic has come out in all the presentations. We need to be able to provide integrated analysis to those who have to set a course to redress what is redressable in terms of climate and the destruction and pollution of our ecosystems. So we need to be fully and absolutely focused on how we can understand to the level that needs to be understood, not just by science, but by society, to support the changes that need to take place, to harness and unlock the potential of the ocean for the people living around it, so that we can actually move to a systemic shift. We need nothing short of what I've called before a blue enlightenment. But what does this mean? It means that we need, as we've seen today, to work from pole to pole. We need a systems level approach to the Earth's great system. We need full international cooperation and mobilization of research, innovation, society, policy, and citizens. We need open science to accelerate this transition to shared solutions. And we need science policy to become a central part of the task of all of us involved in interpreting what is happening and what needs to happen. If we're going to make the ocean feel like home for people, we need to bring it home by explaining in a way that people can understand what it is that they need to take account of in the very difficult decisions that lie ahead. So at 3 levels, we need to conduct this change in building this new vision. At international level, we're in an extraordinary week here where we've seen the launch of the UN Decade of Ocean Science for Sustainable Development. We see the ocean moving to the center, the nexus of ocean and climate of the IPCC assessments, and the meeting of the COP later this year will draw attention to that. The work that's going on biodiversity in IPBES and at the global level will continue to mainstream the situation and the dilemma of the oceans. But we're mobilizing through our All-Atlantic initiative, and I want to thank our Portuguese hosts for doing such a wonderful job in convening this in such difficult circumstances. Our communities of research Atlantic in the sea basins of the Mediterranean, the Baltic and the Black Sea, we're building not simply an alliance of researchers, but a community around the Atlantic that can try to unlock and decode what is happening and provide the solutions. At the European Union level, we're putting our means where our destination is. You've seen the last call of Horizon 2020, the framework program, with a European Green Deal call to try and accelerate some of these breakthroughs. And we'll be seeing very ambitious outcomes in terms of a digital twin of the ocean and a long-term climate observation systems approach to address a number of different parts of the different oceans. We're about to begin the journey with Horizon Europe, a €95 billion Research and Innovation Programme with a new partnership on a sustainable blue economy. And very excitingly, which we've been discussing again this morning, we're about to launch a new moonshot, the mission Starfish, to restore healthy oceans and seas by 2030 by a massive concentration of effort from science, society and investment on restoring our ecosystems, cleaning up pollution and decarbonising the blue economy. And that has also been reflected in a new policy framework developing a sustainable blue economy, which came out just last week. And then at project level, I mean, we've seen these fantastic presentations today from Gerard and Jean-Baptiste and Elaine. We are looking at stepping up the ambition. We need systemic approaches to systemic problems. We need to develop an Earth systems science logic, as we've seen in the Blue Action project and the SOCHIC projects, from Arctic to the Antarctic, from pole to pole. We need integrated ecosystems assessments of what is going on in our ocean. We need models for sustainable development. We've seen this with Triatlas again, coming forward with the building blocks of what will be a future integrated system. We need a fit-for-purpose observation prediction system that is not just for the scientific community, but has to become as mainstream a part of our future world as the public infrastructures that have informed the evolution of society so far. These kind of integrated observation systems, which are so critical to our futures, have to become as mainstream as street lighting was in the Industrial Revolution. What science needs to do for society, metaphorically, is to turn the lights on in the ocean so we can see it as it is and what it needs. And at project level, we now have a vast portfolio of projects, which I think you all need to begin to mine and connect with and come back to us on. So this is a huge moment. And I think listening to what has been discussed and looking at what is going on in the Azores or in the digital Azores, we're dead center in the middle of the ocean, and we're dead center in the middle of a journey that decade. Our planetary science, in the end, must become a vernacular planetary language for society as it once was. And this means that science and policy, science and people, science and the economy need to start talking the same language and be on the same page. So to conclude, the vision for the ocean, as I said, is a vision of the ocean. The ocean has to become second nature to us in our thinking about these decisions ahead. It is a vision of the ocean that is integrated, accurate, predictive, and publicly understood and embedded in our daily lives. And to do that, we need to complete the Blue Enlightened, our understanding of the ocean components, the physical, chemical, biological, the tipping points, the predictive needs, and all that is linked to that. We need to value the ocean, not simply in the way in which everybody in this conversation does, but we need to build out of natural capital and natural capitalism. We need to value the ocean. We need to value its potential in terms of mitigation, adaptation. We need to value what it can do for us as a society. We need to value what it can do for the people who depend on it for their livelihoods, for their food, for their work, for where they live, for their communities. We need to value the value of the cycles, the biological pump, and we need to be able to build on that to create a sustainable and natural blue economy. Thirdly, we need to put in place integrated ecosystems assessments that give us the kind of knowledge and the ability to understand what is happening and what needs to happen at the level and the detail and the time scale that is beyond the current array of what is available to us. And we see very promising signs in the projects. And we need to be able to build our common climate future based on accurate prediction and an understanding of what the dynamics will mean for the life cycle systems that are operating in our ocean. Last but not least, we need to build an ocean citizenship. And this is what we're doing here today in these days in the Azores. We're moving from being a research alliance around this great Atlantic Ocean from pole to pole to become an Atlantic community of people who take the knowledge that we have, harness it, share it, communicate it, and build, we hope, a better future for our ocean and a better vision of the future. Thank you.
Thank you very much, John. That was great. So now we have, we're actually doing very well on time, so that's great. So now I'm going to introduce the panel, and if I can ask everybody to in the panel to put their videos on, as well as the speakers from before. And John, I'm aware that I think you will stay, so that's great. We now have 3 new panel members that you haven't met before, and I will briefly introduce them to you, if I can find them in my list of speakers. So we have Avelia Rivera Arajia, who is a professor and researcher at the Autonomous University de Campeche in Mexico. We have Jorn Schmidt, who is the chair of the Science Committee of the International Council for the Exploration of the Sea. And we have Isabel Ansorge, who is, sorry, I knew I was going to get that wrong.
It's okay.
Observational oceanographer and professor of the Oceanography Department at the University of Cape Town. The reason why it's so weird is that she's in South Africa, but not without a South African last name, so it confuses me. We have these 3 panelists, and we have the speakers who spoke before, but I am going to start off first with a few questions to the panelists so that everybody can get to know them. And I don't believe that there were any questions to the panelists in the questions and answers, which would obviously make no sense because you guys didn't really know that they were coming or know what they were going to say. So I'm going to start off with a question each for the panelists. So I'll start with Avelia. Can you tell us what are the major challenges for the Atlantic coastal zone in Mexico, and specifically with climate change as it's coming? If you can.
Yes, sure, Sheila. Thank you.
Thanks.
Good morning, everyone. Or good morning in Mexico, at least. The coastal zone of the Gulf of Mexico and the Caribbean is extremely vulnerable to climate change impacts, especially sea level rise, floodings, beach erosion, and extreme weather events such as hurricanes. The most vulnerable area are the coastal states of Veracruz, Tabasco, Campeche in the Gulf of Mexico, and in Quintana Roo in the Caribbean. Mexico has over 11,000 kilometers of shorelines in coastal areas, and despite that, a national policy for coastal and oceans was published very recently in 2018. And we have a law that protects only 20 meters as coastal zone, very recently reduced to 10 meters. There are laws on ecological equilibrium that protect habitats in certain areas, but they do not take into account the vulnerability and predicted climate impacts to the coastal zone. Besides that, urban development has significantly affected coastal ecosystems, including mangroves, fringe areas, beach dunes, shallow seagrasses, and coral reefs. And at the same time, coastal developments and transportation and communication infrastructure are impacted by climate change events. Development pressures combined with climate change impacts and the lack of regulations and adaptations programs make the coastal zone extremely vulnerable in Mexico. Listening to all the fantastic projects that were presented and how much we in Mexico need to know and understand, I consider that science for diplomacy is most required.
Thank you very much, Avelia. Okay, so again, if anybody has questions to our panelists, then you can also put them in the question and answers. Next, my question to Jorn is, how does ICES ensure that the newest climate science research is included in the advice you give? I mean, there was quite good examples of some of the modeling that's being done in some of these projects. So how do you guys do that?
Yeah, thank you very much, Sheila, and thank you very much for having me here, and also good morning, good day, and good evening, and good night, wherever you are on the planet. And I quickly scrolled through the participant list, so there's a lot of familiar names. So hello to everyone in the list, and also, of course, to the new ones. That's a very good question, Sheila. And the way that we are doing it, or have been doing it in the past years, is that it was more, implicitly included through, the general data that we were including in producing the advice, meaning that it was kind of in the data on, the fish abundance distribution. and we haven't been really explicitly taking it into consideration. However, I mean, it has been mentioned in one of the presentations, the work on forecasts, and the working group on seasonal to decadal forecasts. It is an ICES expert group and working group led by Mark Payne, DTU Aqua, who's actually doing that, and now we're exploring how we can use that information to be built in. And one way of doing that is we do also work on the integrated ecosystem assessments, and they are feeding into a product that are the ecosystem overviews. And we are currently exploring how we can include the climate information into the ecosystem overviews, which are kind of an information about the status of the different ecoregions in the ICES areas, meaning spanning the whole North Atlantic. And we do have a workshop coming up actually in September, October on, I need to read out the name, we have so many different workshops, on pathways to climate related advice. So really looking into how we can make that more explicit. I think it's almost approved, the workshop, so I'm announcing it without knowing if it's actually finally approved. However, once it is approved, we will put up the announcement, and then of course all the experts are invited to register and attend that workshop. Thank you very much, Sheila.
Thanks, Johan. That was great. Okay, then we have a question for Isabel. Given the escalating concerns over climate change and the impact that it has on the ocean, how are we building capacity in ocean sciences? And what novel examples do you have, you know, in your country?
Thank you very much, and hello to everybody from all over the world, I guess. Thank you very much for the invitation. So I've been lecturing students for the last 20 years, and one of the questions that I always have from students is, how can we go to sea? How can we are oceanography students, we're learning the theory in the classroom, but we really want to get a hands-on experience. And so I think what's critical, and there is this common thread that is running through everybody's presentations, is the need to look at the next generation and to engage with them and to enthuse them to stay in the sciences, particularly in light of, you know, fewer jobs. Although there are lots of opportunities, it's getting harder and harder to find permanent employment, both within academia and within various research institutes. And so one of the things is to raise that potential and take them to sea and give them experiences that are going to be life-changing, and possibly steer them into considering staying within academic or in scientific research. So one of the things that we started in South Africa about 5 years ago was a floating university. And this evening at about 6 o'clock, so 6 o'clock South African time, so I guess it's the same timeline as Europe, there will be a side event on floating universities. And the reason we did that was, and I'm sure a lot of countries who have a polar program or have access to research vessels are limited as to who they can take on these vessels. So if we look at the South African example, we have an Antarctic vessel known as the SA Gullis 2, but you only have access to that ship if you are involved in an Antarctic program. Now, science in South Africa is much bigger than just the few universities that have access to this vessel. So by opening up a floating university, what we've been able to do is open up the ship to all universities across South Africa. And if you think of Britain and you think of Germany, you have exactly those examples as well. You've got the Polarstern, you've got, you know, various James Clark Ross in Britain, but who of the universities have access to that vessel? So that's something that we've been questioning a lot. So what we now do, we open up the vessel to anybody that is willing to apply, and we have a very competitive program, but the deal is every university must be represented in the student cohort. And it's a cruise that we run in conjunction with a large survey across the Gullis Current. We take the students for 10 days to across this research line, this monitoring line that we have. And we have about 45 students and about 30 lecturers. Every year we run this. The students spend the time either working on the deck or in the classroom. Now, this is something that has been going on every vessel. I mean, I've been training students at sea, but I've been training students from my university at sea. And I think the main thing is to create an open and fair program that allows university students from every country to have some chance at getting involved in a research vessel. And if you are able to do that and really inspire them and you give them this lifelong experience, I think you're going to really build an incredible generation, a new cohort of marine scientists that are very, very well knitted, very well connected, and have a good understanding of how difficult it is to get ocean observations and to obviously link this into our greater climate, ocean, atmospheric models. So yeah,
Thanks.
That's my take.
Yeah, thanks. I will actually add that I know that the Eurofleets Plus program, which is a research infrastructures program in Europe, actually has that facility. As far as I know, young scientists can also apply to spend some time on some of the ships, and that is, you know, encompasses quite a lot of ships in Europe, but also a few that's I think from North America as well. So if anybody out there is interested, it's a great program. Okay, so now I see we've got loads of questions, which is great. The first question is from Vito Vitale, and it is to Maria and possibly also to Andre. So he says that science and scientific priority and questions is not the only forces that we have for science diplomacy. It's not the only thing that's out there. So how do we avoid those geopolitical dynamics that can influence too much and prevent or influence the actions that you want to try to get to? I don't know if you have an answer to it's a difficult one, Mary and Andre.
Thank you. Let me start off, and I'll share the reply to this question with Andre. I think it's a really excellent question, and it also requires a complex answer. But first of all, geopolitics, it's a reality. It's not going to go away. It's unrealistic to think that it's going to go away. And we also live in a post-truth world. We live in a post-truth world. Science can be used as a soft power that can even influence geopolitics to advance social, environmental sustainability informed by science. But this can only happen if science has the opportunity to speak and if high quality information is shared so that people and societies can be empowered by it. So combating misinformation and disinformation and creating opportunities to bring science into the everyday lives of everyone on the planet, it really must be a priority for our work. It shouldn't just stop at creating science and then just sending it out to society without any kind of dialogue. You can't just go one way. So initiatives like the Decade of Ocean Science need to create opportunities. It must also address the challenges presented by misinformation and disinformation. And so we need dialogue, we need engagement in science with decision makers, with the general public, and we need to have stakeholders and decision makers helping to co-create the science that we're doing. And so the integrated ecosystem assessment approach like Mission Atlantic is doing, it will create opportunities for doing that, but there should be others as well too. So, and I would open this up to Andre to also hear what he has to say. Yeah.
Thank you, Marian. Hello, you all. Hi, John and all friends. This is awesome. And I love speaking of it. And I'll just take the lead also from a question that Cristina Guerdes put about the BBNJ negotiations and how we see that happening now. So science diplomacy is actually trying not to keep things in their little boxes. So it is trying to break the silos. We absolutely need to consider geopolitical forces, and science is not political. It's not away from political values and social values. And as soon as we face reality and embrace this, the sooner we will be able to accomplish something together. So that means that we are trying to develop new methodologies of taking up this. So you take, for instance, the whole quest for incorporating traditional, indigenous, and local knowledge. When you talk about the biodiversity beyond national jurisdiction, what is the force that those kind of knowledge will be taken up into the science, into academia? And you might think that it's far away from them, which is actually not. It has been demonstrated through the scientific evidence that there is a linkage between those. So there's no way in the modern world that we live today, in this pandemic world and post-truth, as Mary was saying, that we're going to be keeping doing things as we've done before. Business as usual will not solve the problem. So we need to start considering geopolitical forces. Best way to do it? Become the best pal with a diplomat. Learn how they think, learn how they eat, where they go. You know, those kind of creatures are really tough to get a hand on. And top of all, if we are to become truly transdisciplinary, cross-disciplinary, whatever disciplinary, we need to start it from somewhere. So let's open the frank discussion and put our values up front and understand how they are built up and how we can manage them together. Thank you.
Thanks, Andre. That was great. Okay, so our next question, there's actually 3 questions from Larissa Lorenzi. I might mispronounce your name, sorry, from DG Research. And she's asking all of them to the Blue Action Group, which I think is you, Gerard, if I'm not mistaken. And she's asking, as a follow-up to your very good results, how do you think climate services will be taken forward after your project is completed? And then for the sustained observations of the Amoc, what will the future funded project needs to focus on? And then finally, besides the case studies that you developed, what other case studies should be undertaken? So if you can sort of wrap those into one answer, that'd be great. Thanks.
Certainly, I will start with take the 2 case study questions and then think about what we can do going forward. So within Blue Action, we had a number of case studies. We looked at fish forecasts. We looked at developing Arctic tools for prediction, and we looked at developing very specific things for on the scale of for a specific ski resort forecasts of snow. So, I mean, taking these forward, so some of those have a legacy beyond it. So we've set up web portals so that they can be exploited beyond the duration of the project. But taking them forward, we've also identified where they need to go as well. So for example, the fish forecasts, we've proved that we can make fish forecasts and we've proved that they are accurate. But the next step is to really integrate those into a management strategy. And so that they would be brought in and that the real value of the physical predictions, the physical observations leading to the physical predictions, leading to the fish forecast can be integrated into a management strategy such as that. So that's where we would see that one going. There's always case studies that would have been interesting to do, and I think we're also always learning. So, you know, the duration of a project is a couple of years, and during that time, new things emerge. So one thing that's really interesting that has emerged recently is links between Amoc and ocean circulation and linking into sea level. So for many years, it was kind of considered that ocean circulation was a relatively small component of sea level. But now recent studies have shown that there's actually a substantial decadal component of sea level from the ocean circulation. And so I guess JB will tell us that, of course, if Antarctica melts, the slowing down of ocean circulation won't matter very much for sea level, which is very true. But of course, there's a range of scenarios, and Antarctica may not melt so much, and the Amoc might collapse completely. So these are 2 very different scenarios in terms of changing sea level in the future. In terms of what needs to be funded in the future for Amoc research, I really see building into a sustainability of the Amoc observing systems. We're in a comprehensive state at the moment in terms of the projects that have built up, but these are not often funded on short-term funding basis. And the best way to secure their future is really to tie them into the value chain and really show the importance of them. So I think one of the ways we can do that is really to tie them into the predictions. And I highlighted in my talk the links between ocean circulation and that decadal predictability. So that predictability on timescales of 2 to 5 years. So linking in like that. As I say, we're also always learning. So we're also learning in recent years about the role of the Amoc in primary productivity and in terms of the nutrient stream. So that poses a challenge for the observing systems. We need to put the correct sensors on to observe these changes. We know that the area in the Northeast Atlantic has been highlighted as being even more important than we thought it was previously. And when we look at the observing systems, there are certain gaps that we need to fill. So I think all the way through that, we want to look at kind of sustaining the observing. We want to build it into a predicted ocean, like John was saying. And we also want to, bring it all the way through to applied projects. So one thing, of course, is if I said tomorrow that sea level is going to rise by 1 meter, all the engineers around Europe would know, oh, I need to do something. I know what I need to do. If I tell you tomorrow that the Amoc is going to decrease by 30%, I don't think anybody really knows what you're supposed to do with that information. So working on transmitting, understanding on a wider basis what this information means and what you can do with it is a really key area also.
Yeah, that's very, very true. Thank you, Gerard. Okay, so then we have a question for JB. It's on the SOCHIC project, again from Larissa. She's been very good at making sure that we have something to ask, which means I don't get to ask the questions I want to ask, but that's okay. So the question is, if your project were meant to continue or were to continue, what is the future research that should be done for the Southern Ocean? It's kind of a similar project to question to what you asked for Gerard.
Thank you, Shelley. So I think there's three main themes that we actually must pursue and clarify. The first one is that I'd like to mention is the impact on ecosystem of the changes that we observe to better understand in the Southern Ocean, which I mentioned host unique biodiversity, but to better understand how the climate change, but in addition to other human-induced pressure, impact the ecosystem. And there's feedback here, so there is, of course, the influence of climate on ecosystem, but also the influence of ecosystem on the carbon cycle. So I think we really need to pursue and to clarify what are impacts on ecosystem of the changes, the rapid changes and surprising changes that we see in the Polar Ocean, and especially in the Southern Ocean. The second aspect that I think we should try and understand is and which is not entirely clear, is how the two poles work together through the ocean. And so our Southern Ocean circulation changes and our Northern Atlantic circulation interplay together. There's plenty of research in the North Atlantic. There's growing research in the Southern Ocean, but there's still sometimes a link between the two poles in terms of the connections. I think that's something that that should be also clarified and worked on. And the final theme, I think that's very important that we put more effort on, is the interplay between change in the cryosphere, in the ice sheet, in the sea ice, and change in the oceans. There is many interactions there, many very complex interactions that we still struggle to understand. So we need to take state-of-the-art ocean science, state-of-the-art ice sheet science, and put it together to better understand the ocean changes and also the ice sheet changes going on in the future.
Thank you, JB. So then a question for Elaine. Elaine, the question is by Natalia Gallo, a postdoc from Bergen, and she's asking what have been the greatest challenges in developing the integrated climate ecosystem prediction system, and do you also include possible changes in fish behavior?
Thank you for the question, Natalia. So the challenges, so we're halfway through this project, so this is still happening. I think right now the biggest challenges have been that the climate models and the ecosystem models are rather different shaped things. So the Earth system models are large gridded machines, and the ecosystem models are more kind of more like a process based thing. So it's kind of interfacing those two rather different shape models, and so those are quite technical challenges so far. We may not have come across the greatest challenge yet. So fish behavior, yes, that's absolutely included. I mean, it's crucial to know how fish respond to changes in all sorts of parameters in the ocean, coming from all sorts of drivers. So we're not only considering many drivers, but also considering how those drivers interact. So whether there are complex interactions between those, and thinking about the potential for regime shift. So fish, for the ecosystem moving into a totally different parameter space as a response to a driver, you know, be that fishing or a change in the temperature or pollution event, for instance.
I'm going to ask my follow-on question because I'm obviously, for those of you who know me, I'm actually a modeler. So I'm going to ask, so in your models, you're saying that you have issues with sort of linking these two models together. Are you planning to do it all in one big numerical model, or is it actually a physical link between one model and the other? And then my question is, how have you been with getting the feedbacks between the models?
Okay, so I'm not a modeler, Sheila, but I'll do my best. So the models are integrated, so they will be components that work alongside each other, and the feedback will be dealt with like that. So moving away from the system where everything is done offline and the output from an Earth system modeler is given to the marine ecosystem model, and some work is done there to try and interface the two. So it's going towards this integrated system.
Okay, thanks. That's probably good that you were not a modeler. Otherwise, we would have gone off-piste completely. All right. So then the next question I'm going to ask is by Christina Gerda. And it's a question for you, John Bell, and for Mary. The idea of ocean citizenship and the role of science diplomacy is vital for our future. What plans are underway to introduce the results of this work to policymakers, including the European Commission and the European Union member state representatives that are engaging in negotiating the UN agreement on marine biodiversity beyond national jurisdiction? And then it follows on with programs like this for integrated ecosystem assessment could play a major role in stimulating cooperation and hopefully a mechanism for implementing the new EU UN agenda. So what are the potential next steps that need to be taken? And I think I'll ask John first, although he looks like he's not wanting to talk to us.
No, I was taught by my science teacher to take notes when you're in a room with brighter people. So I'm taking note here because I'm very interested to know. My question is, what do you think we need to put these systems in place so that we have the answers by the end of the decade? So Christina, thanks for your question. There's a number of different moving parts to this. So there's the actual official processes where member states, regions, and other actors are inputting into both the scientific process with IPES and the political processes that lead to the Convention on Biological Diversity at the end of the year. Similarly, we have an array of different kind of processes that are connected, but they're in different areas. So for example, we have a very in place for EU policy. So there's the basic level when you're dealing with stakeholder engagement, down to something which we're looking at trying to embed, which is deliberative democracy and deliberative participation infrastructures in political science that could be used at local and other levels to help to inform those who are trying to take positions in either local decision making or global decision making. There's a huge array of work going on in terms of curriculum development. I'm trying to break down the idea of ocean citizenship. The basic problem is the emotional disconnect between people who do not live or depend on the oceans and the significance of the ocean in their lives. And that is going to have to be addressed at a number of different levels. One is actually bringing the science that we're talking about here into land and embedding it in a, can I use the word vernacular, using the examples and using the choices. We need a kind of a Richter scale of risk that people can understand what it is they're being talked to about and talked at about. Mary said earlier on, it's not a one-way process. Most people have a broad understanding that things are changing, and I think the pandemic has helped people to understand that there is a connectedness and a need for evidence in addressing that. I think most of what we've done in the European Union in this huge reframing of what the European Union is for, and that's what the Green Deal is about, is to set a direction in policy that these are the goals that must be attained and that everything must be used to do that. So if you take the very complicated area of investment and finance, much of which has been going in the wrong direction and to the wrong places, we've done a lot of technical work on taxonomy, which means that the people who are lending money to people are required to do it in a way. So what we've tried to do is to break down all the different levels of policy. The question, of course, is how do citizens, or how do people consider themselves to be members or citizens of the ocean? And in summary, there's all kinds of different ways of doing that. Isabel, what you're talking about, we need a university of the sea, and it shouldn't be simply for, it should first and foremost be for researchers and scientists, but it should also be for something that I'm trying to push for, which is, you remember people, maybe some of you had to do military service. Andrea, you look old enough to be somebody who had to do military service, to have the opportunity to do planetary service, that citizens can actually go and work on solving some of these problems. As Mr. Biden has brought forward a kind of a similar process, we're looking at that in the European Union through volunteering. We need to refashion the curricula. We need to make the programs accessible to those who are outside of the tent, the people who don't have top-level university education, access to all of the best things. And we need to build it into the basic. I could go on for an hour, so I'll stop. That's long enough.
Okay, thanks, John. Mary, did you want to add something to that?
I agree with what John has proposed, and I think that these are all really important ingredients to the next steps. I think that we need to really cast a very, very wide net. We need to be very, very inclusive. We need to include diverse voices in these dialogues, and we need to have co-created visions of the future with different parts of societies. We need to build in these connections to nature and bring we need to restore these connections because there is such great disconnect. We need to have we need to also create opportunities. I mean, we heard about floating universities. We can go even more broadly than that, because this is not everyone who will have access to this. We need to mainstream the possibilities for societies to connect with the ocean and also to learn how science works and to make it a part of their lives. And we need to also bolster the critical thinking skills. So society needs to be a part or better connected with science. And then we also need to create opportunities for there to be more participatory approaches to science, not just citizen science, but also engaging decision makers and decision makers and stakeholders in helping. We heard a lot about models today. Why aren't we bringing in more decision makers and stakeholders into helping to create the scenarios that we're trying to test and evaluate? Why aren't we thinking more about what the potential or possible trajectories are for different industries? And so that's what the research in my group is doing for another Horizon 2020 project, MISO. So for the mesopelagic.
Yeah. Thanks, Mary. So I'm aware that we have 3 minutes left, so I'm going to give a minute each to Jorn, Avelia, and Isabel to give us their final words, because the others have spoken more. So Jorn, I'm going to go with you first. 1 minute, eh?
Oh, okay, thank you very much, Sheila. And I have to say that I have a very similar approach to John. I mean, you're better off if you're not the smartest in the room, and I'm certainly not the smartest. So I took a lot of notes. And I think what is really important is that, the working together and facilitate the cooperation, among the different organizations and across, the academic sector, but also other parts of the society. It's not, not only the wider society. I like the idea of an ocean citizen. I might play at the end a little bit of the devil's advocate in a way, because I mean, what you said, John, could have been said also on climate or on biodiversity. And we do need to learn from the lessons that we had from the decade on biological diversity, because in the end, they haven't achieved the Aichi targets. And we need to do better and come to a point in 2030 that we can say, look back and say, okay, we have done better and we have achieved a lot of this. So thank you very much.
Thanks, Jorn. Avilia, I don't know if you have some last words.
Yes, thank you. It would be just amazing to have this whole science for diplomacy, diplomacy in science, and so forth and so on in Latin America, which is very, very important to have partnerships with you guys in Europe. It's the Atlantic, both sides. And in Latin America, from Mexico to the Tierra de Fuego in Chile, it's very important to have partnerships and understanding what's going on with the Atlantic, with the Amoc, with the ocean. We have to know better how to communicate to our leaders, our governors, our citizens, and how to develop our new students. So please don't forget us and
thanks.
Try to be partnered with us. Thank you.
Okay, I think Isabel, you've got 1 minute, and I think they might have
very,
to kick
very
us
quickly.
out.
Thank you. I just want to advertise the side event that is starting at 6 o'clock European time. And this is an opportunity for students who are participating in this meeting right now to engage with a number of academics who are all putting together floating universities, and to hear more about each of the initiatives and to see where the opportunities lie and how they can apply. And I think that the one thing, I know we are all tired of COVID and we're all zoomed out, but I have to say that these meetings are incredible. And for students who lack any funding to travel, here they have the world at their fingertips. They can listen to experts, throughout the world's oceans talk. And this is an opportunity that we would not have been presented with, pre-COVID. So I'm amazed at how the world has kind of taken over with this new Zoom platform, and it speaks volumes for opportunities for the next generation to interact. That's it.
Thank you very much, Isabel. And actually, I think we're 1 minute over. So I would say thank you very much to all of our speakers and our panelists. And I hope you have a good day. I know there's some questions that are unanswered, but we couldn't get to them all. So hopefully you'll get answers from the organizers. So thank you very much. And it was lovely to see you all. Well, it was lovely to meet you all.
Yeah.
Bye, everybody.
Bye, everyone.
Bye.
Thank you very much.
Thank you. Bye-bye.